So let's now run through a few more examples to get some good practice about writing complex numbers in trig notation. We'll take these three examples, 6 minus 2i, negative 2 plus 3i, and negative 4i. First, let's plot each of these points. 6 minus 2i, just think the real part is horizontal, the complex part, the imaginary coefficient here, I end up using complex and imaginary a little bit interchangeably, but I think technically we would say the term with I is imaginary and a complex number has a real part and an imaginary part, but I'm not too picky with the terminology. Anyways, 6 minus 2i down here in quadrant 4. Next, negative 2 plus 3i, horizontally negative 2, vertically positive 3. And lastly, negative 4i. So no real part, no horizontal motion, just down 4, negative 4 on the imaginary axis. Now let's work on writing these numbers in trig notation. First, point A. We need to find the length of this radius from the origin to the point A, and we'll also need to find the angle of rotation. Let's find the radius first. We know we can do this by seeing it as the hypotenuse of a right triangle. Horizontal side, positive 6. Vertical side, negative 2. We're really going to hold on to the negative signs here, particularly when it comes to us finding the angle. So I'm just starting my habit right now. When I look at these triangles, if I'm down here in quadrant 4, my vertical part is negative. I'm thinking of my side actually as having a negative value, just for this type of a problem. It won't matter when I go to that expression square root of x squared plus y squared. These exponents of 2 always make positive values. We end up with 36 plus 4 in the radical. Square root of 40 we could simplify equals 2 radical 10. There is the length of our radius. And now we need to find the angle of rotation. From before, we consider horizontally to the right as initial position 0 degrees. So this point that's down here in quadrant 4, we do need to think of this rotation counterclockwise through quadrants 1, 2, 3 into quadrant 4. But to find that angle, we will use trigonometry and first find this angle inside the triangle. We have a few different ways we could go about doing it now that we have lengths of the horizontal side and vertical side and the radius, so we know adjacent and opposite and hypotenuse. The method I choose to use is tangent. That way I can use the numbers, the coefficients that I see right here in this complex number. I know that tangent of this angle equals opposite side over adjacent side, or y over x. Negative 2 over 6, simplify a little bit, negative 1/3. And since I know tangent theta equals negative 1/3, I can use an inverse trig function. Theta equals inverse tangent of negative 1/3. It's not one of our main increments on the unit circle, so I'll need to punch this into a calculator. In degrees, I get approximately negative 18.43 degrees. And I know that I've got this negative angle measure putting me in quadrant 4 because inverse tangent only provides answers in this range negative 90 to 90 degrees, but quadrants 1 and 4. We would like to make an adjustment so that we see this angle measure between 0 and 360. So we'll add one full rotation, 360 degrees, 341.57 degrees. That's good. It is an angle measure that we know is in quadrant 4, exactly where we see this complex number, 6 minus 2i. And we have all the information we need to write it in trig notation. 2 radical 10 times cosine 341.57 degrees plus I sine 341.57 degrees.